Good morning, class. Welcome to Tech Math, section 5.5, real numbers and their properties. In the first four sections of this chapter, we looked at real numbers, what they are. We went from our good old buddies, the natural numbers, and then we added 0 to make the whole numbers, and then we added the integers, positives and negatives. Then we got to rational numbers, any number that you can write as a fraction. And then we wrapped it up with irrational numbers yesterday, all these radicals. Well, we have to be able to describe how these guys work together. Here's another graphic organizer, if this is better for you to think about the way that these numbers relate to each other. Remember, natural numbers down here at the bottom, and we add 0 to that, those become the whole numbers. We bring in the negative integers, that becomes the integers. We bring in the fractions, that becomes the rational numbers. And between the rational and irrational numbers, we get what are called real numbers. Now, I don't want to scare you, but there's a whole thing called imaginary numbers. We'll get to that a little bit later. Anywho, when we talk about these different numbers and like their groupings, you can see like the natural number grouping, the whole number grouping. Within their elements, we can talk about them being a closed function. Closed means that if an operation is performed on these, this set is closed if the outcome is the same set. So example, if I go 3 plus 5 equals 8, well, that's a natural number plus a natural number, and it's giving us another natural number. So this is a closed operation. We like this. However, if I go 3 minus 5 is negative 2, I have a natural number minus a natural number, and I'm getting an integer. Oh, that's not good. So that is not a closed operation. So in your homework, you're going to be finding closed or not closed operations as you go. Well, with that knowledge, we can then take it a step further and talk about a couple of the properties you learned about back in algebra. And so here are two of them, the commutative property. Actually, there's three of them: commutative property, associative property, and distributive property. So the commutative property is the property that basically states that the order in which you do the numbers for addition or multiplication doesn't really matter. Like a plus b is the same as b plus a. 12 plus negative 5 is the same as negative 5 plus 12. Both of them will give you 7. Same is true for multiplication. A times b is b times a. 12 times negative 5 is equal to negative 5 times 12. They will both give you negative 60. So that is true for addition and multiplication. Commutative property, not so good for division and subtraction. Not so good. Okay? So commutative property, addition, multiplication, we like it. The associative property, also pretty good for addition and multiplication. It's going to work. Associative property, this is the one where we bring in our parentheses. So if I have a plus b plus c or a plus b plus c, they're going to be equal because it's all addition. There's no fancy subtraction in here. It's all just straight addition. And so it's kind of like negative 6 plus 8 plus 2 as compared to negative 6 plus 8 plus 2. Well, negative 6 plus 8 is 2 plus 2 gives us 4. Negative 6 plus 8 plus 2 is 10. So negative 6 plus 10 is also 4. So the additive associative property works for addition. The multiplication piece, same kind of concept. If I have 3 or more that are all multiplying together, I can do them in whatever order I like. A times b times c as compared to a times b times c. Well, it's like saying 7 times 25 times 4. Is that equal to 7 times 25 times 4? 175 times 4 is 700, and 7 times 100 is also 700, so that works out just fine. So that's the associative property. When we look into the distributive property, distributive property of multiplication. For addition, this is where we distribute. So this is that third property I mentioned. When we distribute, this is like taking this a, and it's actually going to be a times the b, also a times the c. So a times b plus a times c. You see here, 13 times 23 is like saying 13 times 2 plus 13 times 3. I'm sorry, 13 times 20 plus 13 times 3. So 13 times 20 is 260 plus 3 times 13, which is 39, gives us 299. Distributive property also works for subtraction. So I can distribute this multiplying a to both the b and the c. So I'll have a times b minus a times c. Here we have 13 times 19. We can say, well, 19 is actually 20 minus 1. So 13 times 20 we know is 260 minus 13 times 1, which is 13, gives us 247. Distributive property, associative property, and commutative property are 3 properties you probably have seen before. They're on pages 222 and 223 if you want to review them. Some of your homework is going to be seeking to identify the property that's shown. This example here, I've got the parentheses. Everything is being added together. This is going to be the, pause for dramatic effect, associative property of addition. So on your homework, you'll be writing out these kinds of properties. Next one here, we have 7 times x plus 3 is equal to 7 times x plus 7 times 3. This is the, back pause for effect, distributive property over addition. Third example here, we have 12 times 3 times 2 is equal to 3 times 2 times 12. Ooh, there's parentheses. Don't be confused. Don't be fooled. Pause for dramatic effect. Commutative property of multiplication. So as we go through, some of your homework is just going to have you write down which property is being displayed at that particular time in those workthroughs. It's important to understand how these work so that as you do additional math, you can see patterns and be able to solve problems easier. When we talk about simplifying using the distributive property, this is a case where we've got like 4 times the sum of x plus 5, and we can distribute that 4 out. So it can be 4 times x plus 4 times 5, and we will then write that as 4x plus 20. Another example, ooh, there's our radicals. Here they come. 2 times 3, the sum of 3 and radical 5. Well, we distribute the 2. 2 times 3 plus 2 times radical 5. It's going to give us 6 plus 2 radical 5. Remember, we can't really do much more with that radical 5 thing going on. Another one, oh, some more radicals. Oh boy. Radical 2 times the sum of, or the difference of 7 and radical 3. Well, we'll distribute that radical 2. So we get radical 2 times 7 minus radical 2 times 3. We can simplify radical 2 times radical 3 down to radical 6. So this is the most simple form of that problem. So we're going to have a couple examples where you have to write down which property you're using. You're going to have a couple examples where you have to find the simplest form, and a couple where you have to identify the different real numbers. If you have any questions, please review the video, reread or read for the first time the section. And if you still have questions, please ask. Here's the homework for this section. We have read pages 221 and 224. That's where we're going to reread and review, close, distributive, commutative, associative properties, all those bits and pieces. The homework itself is found on 224 to 226. And here's the breakdown. For numbers 10 through, it's basically the evens, through 28. You're going to be determining how those fit in those different sets, like natural numbers, integers. So you're going to kind of work through those different problems. For 32 through 40, you're actually writing out a response. So make sure your response is well written and you're providing an example. 42 to 56 are some work problems. Do the evens. 58 through 74 are a couple more work problems that have been selected. And then we're going to wrap it up with 76 to 88 even. These are actually kind of fun. They have an activity, and you have to determine whether that activity is going to work for that particular property. For example, for number 78, it says, writing on the blackboard and erasing the blackboard, we need to figure out if that's going to be a commutative property. And if so, does the action actually work? So, all right, take some time. If you need help, please ask. You know what my email is. We'll see you in class.